All right, so this week we're actually going to start introducing some elements that have more detail. So we're going to look at when would you use pipe versus sweeps, and how do you look at workflows for creating more intricate architectural elements. And also, I want to look at how do you introduce some more complex structural elements into your model as well. So to start off, I think the first thing I want to look at here is kind of cutting and opening. So let me get rid of all this extra information that I used just to kind of show you the process, and I'll go to my completed model. So I right now I kind of have, at this point, I know that this is going to be my shell. I've done my design process, and this is going to be the final model. So my suggestion is to you, if you did a process like this and you've got all your extraneous geometry, do a save as. Go to File, Save As, put it in an archive folder wherever you're saving it, and then that way you'll still have backup information for when you want to go back to like your basic blocks and create diagrams out of it, which is really important. Make sure that you're not really deleting anything unless you're really ready to move on. So for instance, well, I don't have any of the extraneous geometry here. I'll see if I can find you an example at some point. But you want to keep developmental geometry as much as possible. So during the process here, I created a whole bunch of different curves and everything because I constructed and deconstructed a bunch of geometry in order to get this. So I need to, or I want to, get rid of some of the extra curves that I don't need. So I'm going to do an SEL CRV and delete all of the curves that I've created in this model. Because right now I'm done. I'm just going to modify what I have. So what I'm going to do here is just create a simple punched opening, but it's going to have more detail than your typical opening as if you just cut it in a foam core box. So I'm going to create one that has a frame. So let's see, this is that one right there. Okay. And I'll start off just by creating a box here, and I'll just pull it through and worry about the size later. Okay, so this is an approximation, but for you, what you would basically do is, well, let's do it right. I should do it right. So basically, what I would typically do in this condition, because it's tough to actually locate it exactly where it needs to be, is I don't really worry about, like you saw, I just had this really long extrusion that went through my model. I don't really worry too much if it's a subtractive exercise about having geometry that goes everywhere, because I'm just going to delete it. So I look in the front view and I anchor to a particular point. Then I say how big I need it to be. So at, and I'll make it, let's go with 4 feet by 8 feet tall. And then pull it through. All right, so now that's in the bottom of my window, or on the bottom of my wall, and I'll just slide it over 10 feet, and I'll slide it up 3 feet. And then it's as simple as doing a Boolean difference. However, I want to make sure it doesn't conflict with the back wall, so I do need to be a little concerned back here. Boolean difference, subtract it from this to there. Okay, so this is what you're used to seeing so far, right? We've been training this. It's ready to go. We've got this little frame here. It's exactly the same as you would do when you model something out of foam core. However, what we need to do is give it a lot more detail so that when we see it, if we cut a plan, we've already got all the line work that we need right there in AutoCAD. So it's actually going to turn out to be pretty special, I think. The easiest way, I think, to create a simple frame is to give yourself a rail and do a sweep. So it looks a little bit like this. I'm going to go back to layers, go to layer 5, which I'm using for some basic things, turn project off. And if you have your midpoints on, you can just start there Go up to the top, it might let me, whoops, might let me anchor it at the midpoint. Nope, it won't. I need to go here. Go up there. Okay, so that rail is going to give us the opportunity to just do a sweep with whatever profile we want. So the most simple form is, and let me find where it is in my model, so there it is right there. So these two black lines, let me turn this off. These two lines are where that rail actually lives, between those. So if I develop a profile within that, then that's going to give me the whole frame around the window. And it's as simple as taking a rectangle, going from here and saying, let's see, we'll go up at a 45. I'll scale it down a little bit. Nope, not half inch. Let's see, we're going to go there to... Oh, we're going in inches. Sorry, I got to find out how big it is. Alright, so I'm going to scale this down by 1 inch. Okay, so I made it a little bit smaller. I just need to make sure that it's actually living in my frame. But that's not really going to work here because it's a little bit, it's in a weird corner, so you kind of have to slide it off. Right, so now we have it sort of floating somewhere along the profile of that rail. And like we did with the warped surface on the roof, now we do a sweep 1, and we select the rail, then we select the cross-section curve, and we shouldn't have to flip that actually. Hold on. Rail, sorry, rail, there, hit enter, enter. And you should be able to leave it on freeform, and then it's good to go. Okay, so, you know, now if... What's that? Sorry? So the important part of that I really want to get at is that if I do a section, right, this is the process for creating a floor plan. You select and you cut through the window. And then pull it out. And so the important part of that really is that now you have all of the line work right there. So if you have 8,000 windows in your model, all of it is already live, ready for you to cut. You don't have to edit it in AutoCAD in any way. And when you get to the point of actually modeling the glass panes, then you know it's even more complete. Okay, so it's as simple as changing the profile if you want to do something different. So you can just edit that profile. Let me anchor something on that. So if you wanted to do, for instance, like a double hung, then you could just change that profile and create a recess for it to socket into. Okay, so for those of you who are working, you know, who are going to kind of go back into the collisions project, we are going to need to have this detail, this level of detail. So we're going to have a frame in our windows. I'll define probably some more parameters around how that's going to look toward the end. Once we establish all the deliverables, and then yeah, I'll set parameters for that. So what questions do you have about frames for windows? All right, so now my question to you is, what would you do differently if it was a door?
The door is not going to be lined, it's going to be reset, right?
Right, yeah, the line's only going to have 3 sides. So if you're going to do a door, let me just, I'll pretend that I've got a top piece here. Is that, oh, that is on an angle. All right, so I'm going to do it this way. This door is essentially, what? Oh, I project. Go from there to there. 5 feet. All right, so I've got a 5-foot door. So I'll just start it here. I'm basically just going to draw this to be 7 feet tall, 5 feet wide. That's a really wide door. That's not normal, but
What's the
Okay.
typical door, like 3 feet?
Uh,
A little more than that.
3 feet's pretty typical. Yeah. For some interior doors, most exterior doors. A lot of interior residential doors are 34 inches.
4 feet.
So, yeah, I'm going to line this up, just move it into place, and get it ready for sweeping. Whoops. All right, so then we got to draw our profile, and this one's going to be a little bit different. So I'm going to draw from one side to the other. It's a 1/2 foot wide. So typically with a door, it's going to have something like a 2-inch recess onto it, 6 inches wide. I'll go 2 inches back, 1/2 inch out, and 3 inches up. Whoop, sorry. Darn, sorry. I messed that up. 2 inches, 6 inches, 2 inches, 1/2 inch, 3. I'll go, what do we have now? 6 and 7, so I'll go 3 inches in, 1/2 inch. So I'll go. Right, so I'm just drawing a profile now because this is essentially going to give me the frame that I want. Right, so it's getting more complex. It's not just a simple rectangle anymore. We're creating even more detail that's going to make it an even more intricate model. So now I'm going to move this. Actually, I'm going to move that with 3D on. Move from here to there. And then I can rotate it. There, now it's in place. I can do sweep 1, select that. Oh, whoops, I keep thinking it's another step. That, enter, enter, enter. Okay, so now you've got a very detailed door frame, which is actually kind of more accurate than you'll probably ever need in any of your academic models. But you get the idea, right? With, using these kinds of functions, you can create more detailed elements that when you cut them, they're going to appear, far more convincing in your drawings. Okay, so what questions do you have about that modeling method? All right, so what's that?
It's not necessary, is it?
Necessary?
Yeah, like well, I mean, we're going to have to start doing all that, right?
We are going to, yeah. So again, Iggy and I were talking about how we're going to change things up with this assignment toward the end here to serve both groups. So there will be a list of deliverables that outline precisely when and where this is used, but I've got to prepare you with the tools in order to do that. Okay, so what I would like to see you do is, if you just copy a wall out if you have to, or if you already know some of the windows and doors that you have in your model, I'd like to see you actually go through this exercise so that you get some practice with it. Okay, so let's take, can you guys get it done in 10 minutes? I didn't hear any no's, so 10 minutes it is.
Wait, what are we doing?
I want to see you guys do a door frame and a window frame.
Gotcha.
Is that different or the same as a door?
So a jamb is the vertical edge, and the head is above.
But altogether it's the frame?
Yeah.
What size do you want the buildings to be? Like 20 by 40 by 20 feet?
Yeah, so if any of you guys are confused about the program blocks, if you're following along with my assignment, it's 800 square foot blocks, roughly rectilinear, so about 20 by 40.